I'm Julien Nioche. I live in Bristol. I run DigitalPebble, which is a consultancy doing basically anything to do with text, often on a large scale. So it goes from web crawling with Nutch, natural language processing, or doing machine learning, text classification, and so on. So yeah, I'm the project leader for Apache Nutch, and I'm also a committer on other projects like Tika or Gate, and also contribute quite a few things in the Apache ecosystem. So yeah, in this talk, give you an overview of Nutch, see how to very basic stuff, so how to install it, how to set it up. We'll see the main steps involved in running Nutch, and I'll then talk a little bit about Nutch 2x, which is the a new branch of Nutch, and yeah, then we'll see what the future can be for Nutch and the things that we can expect to see in the next few years. So what is Nutch? Nutch is a distributed framework for large-scale web crawling. Doesn't have to be large-scale. Can be used on a very small scale. Most people do, actually. It's an Apache project, top-level project since May 2010. It's based on Apache Hadoop, and it delegates the indexing and search to SOLR, Elasticsearch, Cloud Search, or other possible backends. A bit of history. So, yeah, Nutch was started over 10 years ago by a guy named Doug Cutting. I'm sure you've heard that name before, and Mike Cafferla. And Doug and Mike actually implemented MapReduce as part of Nutch. And that became Hadoop later in 2006. Another project that is a spin-off of Nutch, so to speak, is Apache Tika. Yeah, yet another Apache project that came out of Nutch is GORA, and that was specifically as part of Nutch 2x. So as you can see, we have two, as I mentioned earlier, we have two branches: the trunk, which is 1x, and the new branch is 2x. They are completely 2x is pretty much a complete rewrite of Nutch 1. So they live completely almost independent lives. And we have roughly a release every 6 months for both versions, so they happen pretty much at the same time. So why do people use Nutch? Well, usual reasons: it's open source. The Apache license is quite business friendly. It's mature. It's been around for over 10 years, so it's quite stable. There's an active community of users and developers. But there are other tools that you can use for crawling. But where Nutch really stands out is that it can be used. It's been used and on a very large scale, as we'll see a bit later. Another aspect of it is that it's based on Hadoop, and it's purely a Hadoop application. So you can have, if you have a Hadoop cluster, there's nothing specific you need to do to run Nutch. You can use it on various distributions of Hadoop. Another reason why people use Nutch is for its features. So, as I said, you can index with SOLR, Elasticsearch, Cloud Search. It has, for instance, implementation of PageRank. And there are loads of existing plugins you can use or reuse or extend in Nutch. And Nutch is really pluggable, so you can easily extend it and customize it to do whatever you want to do. Use cases, well, Nutch is usually used for crawling for search, so to send, to SOLR and so on. Can be building very generic search engines or very specific ones. And in terms of scale, people use it from a single node or laptop or to very large clusters on the cloud. But it's not always used, not necessarily used for search. It's also used for just as a way of acquiring data, and then people do all sorts of data mining things or natural language processing or machine learning on top of the data they get from with Nutch. And to do these tasks, which are not necessarily search related, well, you can use Mahout for machine learning, or UEMA or Gate for natural language processing. And for that, there is one of our projects on GitHub that can be used for doing things like these, which is called Behemoth. And Behemoth is sort of glueware. It's based on Hadoop, and it's basically a wrapper for all sorts of resources. and it's a way of combining them together to build a processing pipeline in Hadoop. So customer cases, so that's a very simple, like two-dimensional representation of typical use cases. On the one hand, you have the specificity of the crawl, so whether you want to do very specific things with you make the assumptions on the data, you use specific tasks. And on the other, on the horizontal axis, you have the size of the data set. The area in green is where usually most projects are. They're somewhere in that green area. Basically, the bigger your crawl, the less specific your task is likely to be. So I'll give you two examples of this from two of our customers. One is betterjobs.com. So for the ones of you from the US, you probably came across that website before. It's part of a group called Career Builder. And for these guys, we have a crawl running on a single server, and we just aggregate content from various job portals, and we extract and normalize the structure of these job adverts. So we extract the description, the requirements, the location, and quite a few other things. And of course, the way this information is represented in the job portals varies a lot from one portal to the other. So it's quite it's a very specific application. We can. We're interested not in crawling as many websites as possible, but just specific ones, and we use specific tasks on them. So the volume of data that we crawl is not very large; it's just 2 million pages, and then that's used to feed a SOLR index at the end of the pipeline. At the other end of the scale, so going towards very, very large size, but very generic processing. We have similarpages.com, which is a client we had in Italy a few years ago. And so for these guys, we used quite a large cluster on EC2. We had up to 400 nodes at one point. And we used Nutch to get as many pages as possible. So we fetched and parsed 3 billion pages. And in total, we had over 10 billion pages in the crawl DB. And that was not used actually to build a search system, so we didn't use anything like Elasticsearch or SOLR, but that was used to find similarities between websites. I think the system is still around, still available. Another use case of Nutch is the Common Crawl project. If you haven't heard of Common Crawl, then it's probably worth having a look. It's a really good project. And what they do, it's an open repository of web crawl data. So they store the data as ARC files on Amazon S3, and the data set they released last year was just under 4 billion documents, and that can be used and accessed freely. And the guys at Common Crawl are now using Nutch 1.7 for their current crawl, with a few slight modifications to the code, and apparently there'll be a next release of the data set, but using Nutch for fetching and crawling, which is great. Okay, so a few words about very basic stuff: how to install it, how to set it up. So if you go to the Nutch website, on the download section, there are two main distributions for the 1x and 2x branches. 1.7 has two distributions, the source and the binary, whereas 2.2.1 has only the source, and I explain why later. And the way you install that stuff is pretty straightforward. You just need to have Apache Ant installed, and then you call that command line on clean runtime. That generates two subdirectories, runtime local, runtime deploy. The first one is just to, it runs, as the name suggests, in local mode, which is very useful for testing and debugging, whereas the second one will use an existing Hadoop cluster to run the stuff. So the second one is a proper Hadoop setup. And what you get when you use if you download the binary distribution for 1.7, what you actually get is the content of runtime local. So all that's something I will, if there's one message I want to hammer in, is that the best way to think about Nutch is to think about it as nothing more than a Hadoop application. So think in terms of Hadoop, MapReduce, and Hadoop data. So the configuration and resources are all in a directory in conf, obviously. But because, as I explained earlier, when you run the stuff, you actually run it from runtime local or runtime deploy. It means that if you make a change to the configuration at the root of the project, then you need to recompile in order for the changes to be copied into the runtime directories. Unless you're in local mode, in which case you can modify directly the runtime local configuration files. So all the configuration is within a file called Nutch site. There's also a Nutch default file, but which is a good practice is to make your own modifications in the Nutch site one and leave Nutch default alone and just use it as a reference, just to see the sort of parameters that are available and what the default values are. And the only thing, you can run it, but the only thing you really have to specify is the HTTP agent name, hopefully using a slightly better value than this one. So to run the stuff, you go, as I said, to the runtime local or runtime deploy directories, and then you have two scripts. One is called crawl, and it's just it does a typical sequence of the steps, which I'll cover in a minute. And the other one is Nutch, the Nutch script, which is used to run the individual Nutch commands. And it's nothing more, the bin Nutch one is nothing more than a wrapper for the calls to the Hadoop jar, blah 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 stuff. So it makes your life a bit easier. As I mentioned earlier, the local mode is great for testing and debugging, but what I really recommend is to use it in deploy mode with, even if it's on a single node, just set up Hadoop as a pseudo distributed cluster and use the deploy directory. Why? Because while you get you have a proper Hadoop setup, so you get your mappers and reducers running in parallel, so things run much faster, and also you can use the MapReduce UI to monitor the crawl, to check the logs, see the counters. So it's a very just the MapReduce UI is a very good tool to see what's happening. If you're in local mode, you don't get any of that, and you have to go through the Hadoop log file to see what Nutch's been up to, and it's not great. But it's good for debugging the local mode, so they're both useful. So that's the the well-known MapReduce UI. That's for doing a crawl, and you can see, for instance, here we have the fetch step going. And by using the MapReduce UI, you can go directly into the logs for a specific task, check that there are no errors or anything, and also you get all the counters, which is pretty useful. I'm not sure you can see them. Where's the laser thing? Here it is. So here you can see the status for the pages that are being fetched at this step, and you can see that you had, for instance, 185,000 successful pages. Some have been moved, some have triggered exceptions, and so on. But it's a good way of monitoring the crawl. So now, the main steps in a Nutch crawl. So they are pretty much the same between Nutch 1x and 2x. And again, because Nutch is based on Hadoop, what we do is just a sequence of batch operations. The first one is the injections, which means we inject some seed URLs into a data structure called the crawlDB, which is where we store all the information we have about web pages. So we initially inject, we give it something to start from. And then we have steps that can be used in a loop. So the first one is the generate. So we select a number of URLs from the crawlDB, and we generate a fetch list in a segment, which is basically a round of fetching. Then these URLs are obviously fetched, parsed, And then we just merge information we got from this round of fetching back into the crawl DB. So if we discover new URLs, then we add these URLs in the crawl DB, or we change the status for a page in the crawl DB. Then you can also typically invert the links, so build a web graph, so relationships between the URLs. And then often, well, you can send the index and send the documents to a SOLR, Elasticsearch, or whatever. And typically, you repeat the steps from 2 to 7 as many times as you need. Or you can use the crawl script I mentioned earlier, which will do all these things just with a single command line. So from a data perspective, so what are the sort of data structures that we use in Nutch? So I mentioned the seed list. That's a pretty straightforward text file. So during the injection, we just generate a crawl DB containing these seed lists. So the crawl DB is a good old-fashioned Hadoop map file. Then when we generate a segment, we within the segment, the name of the segment is basically a timestamp, and the generation adds a subdirectory called crawl generate. The fetching adds a couple more subdirectories with the crawl fetch, which contains the status of the URLs after fetching and the actual content being fetched. At this stage, the content is still binary. It's just a byte array, pretty much, until we get to the parsing, where we add more another status in the parsing, also some metadata that could have been found, extracted from the documents, and the actual text of the document. Then finally, well, I mentioned the update step. So we send the information back to the crawl DB. We can then generate a link DB, which is another data structure in Nutch. So that's when we do the link inversion. And finally, all these things are used for indexing with SOLR. So while the link DB one is optional, you don't have to generate a link DB to index with SOLR, but you will need obviously the segments and the crawl DB. Another way to look at this is in terms of frontier expansion. So the first step is the manual discovery, when we inject seeds that we already know about. The rest is just we discover new frontiers, new URLs. So each sort of cloud here, so to speak, represents one round of fetching. So basically one segment. And you can see we discover new documents here. We can see the links between the documents. Not all documents are useful, which you can see here. So we have ways of controlling the way we discover the new URLs, and we can filter the outlinks. I mentioned that Nutch is extensible, so we have plugins in Nutch. A plugin is basically a collection of classes implementing one or more endpoints. So endpoints are things that are called at specific places in the Nutch processes, and Nutch comes with a lot of implementations for these endpoints. But you can extend this via the plugin mechanism. So yeah, endpoints. So they are in a finite number. So you have obviously the protocol. So Nutch comes with a number of obviously an implementation for HTTP, HTTPS, FTP, whatnot. Same for the parsers. One which is pretty useful when people customize Nutch is the HTML parse filter, which has a slightly different name in Nutch 2x. It's called a parse filter. That is called after the parsing. So we have like primary parsers in Nutch, which convert from the binary content into extract the text and metadata, and they also generate a DOM representation of the document. And then the HTML parse filters are then called after that, and that's where you can have your custom rules for extracting things that are interesting in your pages. So you can use you can use, I don't know, XPath on the DOM to extract, scrape whatever you need. So in practice, that's used very often when customizing Nutch. Then there are other endpoints like the scoring filters, which are used in various places. The URL filters I mentioned earlier, where you want to control the way you expand the crawl frontiers, and the normalizers that make sure that you don't have you have one representation for variants of a given URL. Indexing filters so these two are called obviously at indexing time, and the indexing filters are just ways of generating. So during the indexing, we have a representation of the document that is sent to the backends, which is based on fields, and typically the indexing filters generate fields that are then sent to Solr or Elasticsearch for indexing. And a new feature we have in 1.7 is the index writers. So before that, we had Nutch was pretty much hardwired to Solr, but the index writers allow you to just implement connection to a backend via using the plugin mechanism. So we now, there's a plugin for Solr, obviously, one for Elasticsearch, but you can easily write new ones. So yeah, other features of Nutch. Well, obviously, the fetcher plays quite an important role, being about crawling. So the fetcher is, obviously multi-threaded. One thing that is pretty important to understand Nutch is that Nutch is by default very polite. So the fetcher will queue URLs per host name, domain, or IP, and that's a way of controlling how frequently you will hit a server when you fetch from it. And as I said, by default the values are very polite. Yeah, Nutch also the crawl strategy. So it goes breadth first. You can modify that if you want using custom scoring filters to use different strategies if you wanted to. The scoring is pretty important from 2 points of view. One is that you can use that to then use as a boost for your documents in Solr or Elasticsearch, but also because that's how you define what should be fetched first. So we have two flavors of scoring. One is UPIC, which is just a very simple way of aggregating scores for a given URL, and the other one is sort of page rank like algorithm, which is called link rank. As I mentioned, we have implementations for various protocols, so obviously HTTP, FTP, HTTPS, also a file, so if you wanted to crawl from a file system. And for the, at least for the HTTP ones, Nutch respects the robots.txt directives, again, with the view of being as polite as possible. There are two ways of scheduling the crawl. So one is fixed. You just basically determine that once you fetch the page, you will try and refetch it within, say, by default 30 days, I think. So that can be set at any value you want. But there's also another mode, which is the adaptive scheduler, which will look at how frequently a page is modified and try to infer from that what an optimal fetch rate is for that specific page. We also have various URL filters based on regular expressions, final states, automata, or other things. And same for the normalization. We have ways of normalizing the URLs based on regular expressions. So it's basically just a file, a text file that you can modify accordingly. So some other aspects of Nutch. So the parsing is done with Apache Tika, which means that we can support all the formats that Tika does. So we have literally hundreds of formats that we can deal with in Nutch. We also have some older parsers that are can be used in parallel with Tika. And there are loads of other plugins you can use for doing language identification, just extract arbitrary metadata. So if you think about an HTML page, for instance, you can configure it to say, okay, extract the description, extract the keywords, whatever. And yeah, that thing I mentioned earlier, the pluggable indexing, so that you can send to the documents to index to various backends. Talking about the indexing, yeah, of course we support Apache SOLR. So in the configuration directory of Nudge, there's sort of default schema you can use, and you can just use on the SOLR copy of it SOLR and use that to get started. We currently support the version 3.4 of SOLR, but there are contributions in a JIRA, I think, to get things to work on using SOLR Cloud. Yeah, Elasticsearch, we use the version 90.1, and a recent contribution we had from the guys from Amazon is a plugin for sending the documents to Amazon Cloud Search. So it's still work in progress, but it can be used. But as I said, now that you can write a custom backend for an indexer, it's quite easy to build your own. And we've implemented some to just to generate a text representation of the documents that were crawled, or you could use that to send the stuff to a DB or whatever. So when you crawl and then you index to SOLR or Elasticsearch, as I mentioned, you have a field-based representation of a document, and typically the fields are things like this. You have obviously the URL, the text content, the title, the anchors coming from the web graph I mentioned earlier, and various other things. You can again that's based on the indexing filters that you want to activate or not, and yeah, some of the fields are generated by like plugins that you can configure, like the meta tags one. If you configure it to use the keywords or the description, well, it will generate a field accordingly. And you can also inject arbitrary metadata. So imagine you have in your seed list you have some metadata about, I don't know, a given site that you want to, for which you want to track some specific information you have. Well, you can configure Nudge to so that this metadata will be transferred to the documents found from that site, and then ultimately converted into fields for SOLR or Elasticsearch. So a few words about Nudge 2. So as I said, we have these two branches in parallel. So Nudge 2 is pretty recent. It was released in July last year. We are now at version 2.2.1. It's very similar to 1x. So it's again still MapReduce operations, batch stuff, uses Tika, pretty much the same plugins, delegates the indexing to SOLR or Elasticsearch. The difference is that instead of having Hadoop data structures with the sequence files and the map files, we use a big table like architecture, so that you can leverage all sorts of NoSQL projects to actually take care of the storing the data. And to do that, we have an abstraction over the storage, which is Apache GORA, which I mentioned briefly earlier. So again, yeah, top-level project at Apache. So GORA, it can be seen as ORM for NoSQL databases, but it doesn't do just NoSQL. There's also support for SQL and also file-based storage. The current version is 0.3, and it basically provides implementation for wrappers for a number of data stores like Accumulo, Cassandra, HBase, but also DynamoDB, but also AVRO for the if we wanted to use like file-based storage, or even the SQL one, which I think is not is quite broken, but never mind. Two main aspects to the GORA is it uses Apache AVRO for serializing, and also a backend specific mapping, so you can define how the things will be stored in the data store. So the AVRO schema, that's what it looks like. So that's the schema for the web page in Nudge 2x. So here we can see the different fields that are used and the substructures and everything. And this is used to then generate Java code that is used by within Nutch. Yeah, and then there is a mapping file as well, which is then backend specific. So that's the one for HBase. And that's where you define that, for instance, okay, we have a table, that's the name of the table, the families, and then these are the fields and how we store them in the various per family and qualifier and so on. So there's one mapping file for HBase, one for Cassandra and everything. So then in GORA, so we have these data stores and the operations you can do on the data stores are, well, obviously the basic ones, like get the value for a key, put a new object under a given key, or delete a key. Also, you can also query and get a number of results based on the query, or delete by query. But for us, from a Nutch perspective, what we really use is the wrappers for MapReduce. So there's a GORA mapper or reducer, and also a GORA input format or output format, which means that we in our MapReduce code we can just use this, and it will work exactly in the same way, regardless of whether we use HBase, Cassandra, or even a SQL store. So in GORA in Nutch, so we have obviously a schema, an AVRO schema, which is already there, and the Java code from that schema is already pre-generated. We have mapping files for some of the backends and they can be modified if necessary. But the thing with GORA is that we don't really know what people will be using, what backend they want to use with Nutch 2, which is why when you use Nutch 2, you need to modify the dependencies in Ivy and say, okay, I'll be using, say, HBase, which is why we have only the distribution for 2x is only the source, because you need to recompile the stuff and get the dependencies depending on what backend you want to use. And yeah, this is the link to the wiki page, which is specific to the Nutch 2 tutorial. But again, most of the concepts from Nutch 1 can also apply to Nutch 2. So what are the benefits of Nutch 2? So we still have the distributed storage, replicated, but we have one big table containing everything. So the status, the metadata, content, text. So we don't have any more segments like we had in Nutch 1. So one of the nice little features that we gain from that is that we can resume a fetch or a parse step. So in Nutch 1, if you're say fetching and your fetch job fails for one reason or another, well, you will need to restart the whole fetch, to refetch the whole segment. Same with the parsing. It's different with Nutch 2 because the updates are sent. If a page is fetched or parsed, then it's the backend gets updated during the step. So if it crashes, then if you restart it, it will start pretty much where it left. So it's a nice little feature. Another one is that it could make it easier for other resources, other projects to interact with the data generated from Nutch. So third-party code could use GORA, and if you use GORA in the schema, and you can pull the stuff from, say, Cassandra or HBase. Also, quite a bit of the logic around the low-level logic of how to update something or how to write something is simplified because it's delegated to GORA. But one thing that could really make a difference is that some of the steps in Nutch could be a lot faster, especially the update one. So I'll give you an example. Imagine you have a CrawlDB in Nutch 1, which is pretty large, like 10 billion or something. You want to either, say, inject a few URLs into the CrawlDB or merge back from a small segment, which you will have fetched. Well, in Nutch 1, again, MapReduce, Hadoop sequence files, and so on, the way you do that is you read the whole CrawlDB plus whatever you want to add, and you merge them in the reduce step, and then you rewrite the whole thing. So when the CrawlDB, as the CrawlDB gets larger, this step takes longer and longer and longer, and that's on large crawls that's a bit of an issue because you end up spending more time updating than you are fetching and parsing. So it's a bit of a pain. Well, there are ways around that, but Nutch 2 could be faster because we're not bound to these Hadoop data structures and just to the batch things. We could update information in the table on a more atomic level, so to speak. The drawbacks, it means you have more stuff to install and configure. So if you want to use Nutch 2 with, say, HBase, it means you need to have HBase installed on your servers. You need to configure it. You need to have the knowledge about how to use it. Also means slightly higher hardware requirements, because you also need to have another server running on your machine, and I don't know, it would take probably mean that you need an extra gig of memory or something. Now one of the problems with Nutch 2 is the performance as it currently is. So there is here is a link to on our blog about a comparison we did between Nutch 1 and Nutch 2. And it's not really flattering for Nutch 2. We found that on average, Nutch 2 on HBase was 2.7 times slower than using Nutch 1. The one on Cassandra was 4.4 slower. Now, very important point. This is not about the respective merits of HBase or Cassandra, right? Don't go and quote me saying that I said that HBase was a lot faster. I don't want to be dragged into that discussion at all. It's mostly due to the way things are wrapped within GORA. So, and maybe also about the default configuration we use for HBase and Cassandra, because we just took them like out of the box and didn't modify anything. So again, don't quote me on this. One of the reasons why it's a lot slower is that, and there's a GORA issue on GORA, is that at the moment GORA doesn't filter any of the data that are sent for the MapReduce operations, which means that if you want to fetch just one URL in the table, the way it currently does that, it pulls the whole table on the MapReduce side and then filters just before it's sent as an input to the mapper or the reducer. Hopefully, this will be improved in future releases of GORA. Another thing is that not all the backends have this concept of data locality, so which is quite central for Hadoop. I mean, Hadoop is all about moving the computation of the data. Some backends, like the HBase one, the implementation in GORA is aware of where the data lives, so it tries to optimize, which mapper or reducer will use it. Not all backends have that in GORA. So again, that could be an explanation as to why we have these differences between HBase and Cassandra with Nutch 2. And yeah, it's been around for only a couple of years, not even, so it's not as stable as Nutch 1, which is pretty rock solid. So still work in progress, and in the future, I expect the backend implementations will stabilize. At the moment, if you really wanted to go for Nutch 2, then the HBase wrapper in GORA is by far the most reliable. Again, nothing to do with the merits of HBase itself. It's all to do with the effort put in GORA. What I expect we'll see is that we'll synchronize some of the features with 1x. So there are things that we don't have in Nutch 2 and we have in Nutch 1, and I suppose they'll get added back to Nutch 2 at some point. So yeah, we don't yet have the pluggable indexers I mentioned. We don't have the page rank equivalent, but there's some work done towards that. And also that improvement to GORA that would make, I expect, quite a difference to the performance. Future developments, regarding the project as a whole. So both versions will probably coexist for quite some time. But again, one of the messages I'd like to convey today is that it's 2x is not yet a replacement for Nutch 1. I expect we'll see quite a few new functionalities. So support for SOLR Cloud, I mentioned that. Support for sitemaps, canonical tags, also a new deduplication engine, because the current one is quite tightly bound to SOLR. So there's work towards making it generic so that we could use it with other indexing backends, and also move to the new MapReduce API, because again, as I mentioned, Hadoop came out of Nutch, and some of the stuff we have in Nutch is still very old style. So yeah, we'll probably there'll probably be work towards refreshing all this, which means we could use Nutch on Hadoop 2x. I expect we'll see more and more delegation of functionality to other projects, which we did an awful lot of that in recent years. Before Nutch used to manage its indices and the search directly with Lucene on HDFS, and we had all these codes just to do the search, and there used to be a search server just for Nutch and so on, and we just decided just to delegate that to SOLR, and now Elasticsearch and other projects, and the size of the code shrunk by 50%. Yeah, we'll probably share code with other related projects. Like we have another project on Google Code called Crawler Commons, and it's used by a few other crawlers. And the idea is that instead of all sort of reinvent the wheel, the idea is to just focus, share the effort on some very simple tasks that all crawlers need to do, like parsing a robots.txt file, processing sitemaps, and so on. So expect some of the stuff we have in Nutch, like maybe the protocol handling or the URL filtering, will probably get moved to Crawler Commons so that other projects can more easily benefit from it. And also we'll have to spend less time mentioning this stuff. So yeah, have a look at Crawler Commons. It's quite a nice little project. I think, there is work done towards improving the page rank, like stuff that we have, because we don't have it for Nutch 2, and also is some Nutch code. So now we have resources like Apache GORA, and the idea is would be to use GORA to do the computations on the graph and everything, because that's what it's good at. It means also for us less code to maintain. So if we have something which is more efficient and for less work from our point of view, then we should definitely try and do that. Now, long-term vision, very far, and these are wild guesses, so they might prove completely wrong. But now, as you know, Apache 2 is now Hadoop 2. Sorry, Apache 2. Hadoop 2 is now out of. I think that there's been the first stable release very recently, and that introduces Yarn, a new concept that wasn't in Hadoop 1. And what we can see, I think, is a convergence of batch processing and streaming. So we can see all these new projects coming, like Storm, Samza, or Storm Yarn, which sounds good because it's a mix of it's Storm but using Yarn for the scheduling the resources and so on. And that I've probably forgotten quite a few, because it seems to be a new one coming every week, pretty much. And I think it will be easier to mix batch processing and streaming within pretty much the same environment. For Nutch, this could have quite interesting consequences, which means that we wouldn't have to do only 100% batch operations as we currently do, and some of the tasks would be quite good as streaming. So if we think about the fetch step or the parse step, that could be a streaming operation. So we could be always fetching or always parsing, while at the same time doing some of the operations as batch with MapReduce, like the generation or the update or the page rank will probably remain batch operations, but other things would be like more based on streaming, and that would be pretty efficient, because at the moment the fetching, as we've seen, is just one step. So you're generating, fetching, and then parsing and updating. But while you're parsing and updating and generating, you're not fetching. So that could be an interesting development. And just one reference here. Another project we have on GitHub, Storm-based crawler, which is very, very, very early stage. But if that's something that you're interested in, then maybe have a look. There are probably bits some bolts you can reuse for Storm that could be used for crawling. The project page and all the mailing lists and the wiki page. There aren't any books about Nutch. The only printed reference about it is in Tom White's excellent book on Hadoop, where there's a chapter on Nutch written by Andrzej Białecki. And anyway, if you want to use Nutch, understanding Hadoop is pretty crucial. So this book is a good investment. And also, support and consulting. There is a page on the wiki listing all the people you can hire if you need help.